Hey guys, we're on Unit 7. This is day 4, and we're going to determine if triangles are similar today. All right, so similar triangles have the same shape, different size, but how do you determine if they have the same shape? So we'll talk about the things that we can check out to see if they have the same shape. Okay, but first we got to warm up. This is a trapezoid and only a trapezoid. Is a median MQ and is shown in the diagram below, and they want you to solve algebraically for x and y. So if you notice, some of our expressions have x's in them and some of them have y's in them. So we'll go ahead with x first. And the three expressions that have x in them are those three, and they represent angles. And we have to remember, what do we know about angles in a trapezoid? And there is only one thing. If you remember, a trapezoid only has a pair of parallel. Right? And if we use those as our pair of parallel and this as the transversal, hopefully you guys remember that these two angles here between the parallel lines are called same side interior angles, and same side interior angles are supplementary. All right, so we're going to go ahead and take those two angles, which is 12x minus 4, and add 7x plus 13 to equal 180 degrees. Some of us don't like the setup because we're not using the 6x. However, we don't know what the angle is up here to be supplementary with, so we can't use a 6x. So it's right now a little bit of extra information. Okay, 12x and 7x make a grand total of 19x. Negative 4 plus 13 is a positive 9. If we subtract 9, we get 19x equal to 171. And if we divide by 19, x comes out to equal 9. And we have one of our variables found. Okay. In our next setup, we have to determine what are we going to do with these y expressions. So we have the top, the middle, and the bottom. And if you remember, the median is the average of the bases. Okay. And so we can write our little formula down over here, say that the median is equal to the base 1 plus the base 2 divided by 2. That's how you average. Okay? So if I go ahead and take my median, which is 16y plus 1, and put it equal to my base 1, which is 12y plus 1, plus my bottom base, which is 18y plus 6, all divided by 2. And we're going to go ahead and clean that up. All right, hopefully we got a little bit of room over here. So we'll keep the 16y plus 1. But on this side, we have a 12y plus an 18y, which is a grand total of 30y. And we have a positive 1 and a positive 6 for a positive 7, all divided by 2. Okay. Remember that when you're dividing by 2, not only will you divide the 30y by 2, but you'll also divide the 7 by 2. Okay, and it's okay to get a decimal. So we'll end up with 16y plus 1 equal to a 15y plus 3.5. I'm going to go ahead and subtract the 15y first. We're going to be left with y plus 1 equals 3.5. I'm going to go ahead and subtract 1, and y comes out to equal 2.5. And we just solve for the second variable that they asked for, and so we're finished. Okay. All right, here we go, guys. So remember that when we were proving triangles congruent, we had theorems, right? When we were proving triangles congruent, our theorems were angle, side, angle, side, angle, side, angle, angle, side, 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 and RHL. Remember those 5 theorems? All right, well, we have similar theorems when we're proving triangles similar. All right, so since triangles are polygons, we can prove 2 triangles are similar if we can show that they satisfy the 2 necessary conditions required of similar polygons. Okay, the first one, all pairs of corresponding angles are congruent. Remember that the angles have to stay the same. Okay, when the angles stay the same, that keeps the shape the same. And when they have the same shape, that's how they become similar. Okay, what happens to the sides is that the sides will all be in the same, what they call a ratio, which is just a number divided by a number. Okay, because they use the same scale factor to multiply, so when we divide them, we get the same. Okay. All right. However, there are 3 shorter methods for proving triangles, just like there were 3 shorter methods when we were proving congruent triangles, right? If we didn't have those shorter methods, we would have to prove all 3 sides were the same and all 3 angles were the same. Thank God for that congruent methods shortens it up a little bit, while similar methods do the same thing. Okay. So first shorter method is called AA. Okay, and this stands for angle similarity, is the squiggle underneath after the two A's. So it says two triangles are similar if two angles of one triangle are congruent to two corresponding angles of the other triangle. All right, so in our given information here in the box, if we mark what we have there, I'll show you guys what a picture looks like. Angle S is congruent to angle Y, so they get an arc mark. And angle T, is congruent to angle Z. So they'll get two arc marks, okay? Because triangles have to have 180 degrees inside of them, if two of the angles are already congruent, that means the last angle has to be congruent, right? If you think about it, if you have 180 degrees and you take the same two numbers away, that would leave the same difference at the end for the last angle. And so that's why we don't have to prove all three angles are the same to make sure that the shape is the same. So you could. AAA similarity also works. It's just that this is a little bit of a shortcut because that last angle would have to be matching if the first two angles already match. All right. So that is one of our theorems to prove similarity. Our next one is called side similarity. Now remember that the sides won't be the same length, but the ratio will be the same. So two triangles are similar if the three ratios of the corresponding sides are all equal or congruent. Okay, so this is what this one looks like. In our given information here, they tell us SR is 3. They tell us TR is 8, and that ST is 12. They tell us that YX is 4.5, that ZX is 12, and that ZY is 18. And what we're going to do is we're going to go ahead and remember this, that small goes with small, medium goes with medium, and large goes with large. Okay, so small in the little triangle is 3. Small in the bigger triangle is 4.5. Okay, medium in the little triangle is 8. Okay, and 12 is the medium side there. Okay, large side here, large side here. So that when we compare, we have to make sure that we're comparing one side from one triangle, one side from the other. Okay, so we're going to go ahead and do a ratio, and we're going to divide. And it doesn't matter which triangle you start with, but whichever triangle you start with, okay, you have to keep making sure that you come back to that triangle for the next ratio. All right, so let's go ahead and say that we're starting with the small triangle. And we'll go in order. We'll go small, medium, large. So small side was 3, and we're going to divide that by the small side from the bigger triangle, which is 4.5. This should equal, and again, see how I'm starting my next fraction? So I have to go back to the small triangle, grab my medium side, then go to the large side triangle and grab the medium side. All right. I'm starting my third ratio. So again, I have to go and start with the small triangle, which the only side remaining is 12, and then go to the new triangle and grab the large side, which is 18. Okay. All right. All we're going to do now is we're going to take our calculator and we're going to enter in our 3 fractions. So we're going to do 3 divided by 4.5. Okay. 3 divided by 4.5 gives us 0.6 repeating, which is 2/3. Okay. And then we're going to type in 8 divided by 12. It's the same 0.6 repeating, or 2/3. And last fraction, 12 divided by 18 in our calculator, and 0.6 repeating, or 2/3. And so what happens is that all of the ratios of the corresponding sides are equal. All right, and therefore these two triangles are similar by side similarity, because it was the 3 sides of one compared to the 3 sides of the other. All right, last method. And this is a little mixture of the two methods. This is called side angle side similarity. It says two triangles are similar if the ratios of only 2 pairs of the corresponding sides are equal, and the corresponding angle, it says included, which means that that angle has to be between the 2 sides that you're comparing, okay? And that angle has to be congruent. All right, so let's take a look at the given information that they give us in this one. Okay, TR is 5. ST is 6. XZ is 24. ZY is 28.8. And they're telling us that angle T is congruent to angle Y. All right, so it looks like side angle side, the angles between the sides, but we still have to do the comparing of the sides like we did in the last one. All right, so remember, small goes with small, medium goes with medium, large goes with large. And since we only have two, we'll only have like a small and a large. All right, so small and small, large and large. All right, let's go ahead and compare them. Again, it doesn't matter which triangle side you start with. I'm going to start again with the small one. All right, and I'm going to take the 5, and I'm going to compare it to the 24 from the big one, and then I'm going to go back to the small one, grab the 6, compare it to the 28.8. All right, grab your calculator, and we're going to go ahead and type these in. All right, 5 divided by 24 is an ugly decimal, which if you math frac is 5 out of 24, so it didn't reduce. Okay, 6 divided by 28.8. You get that same ugly decimal, and then so if you math frac it again, you'll get 5 over 24. And so you can see right there that the ratios of the two sides are equal, okay, or the two pairs of sides, I should say, are equal, and the angle between them. And so this is how we get side angle side similarity. All right, and any of these three methods are good to prove two triangles are similar, okay, meaning that they have the same shape, just not necessarily the same size. All right, so we'll answer a couple questions on the back side. I'll see you guys there.